All right, so as promised, we'll be talking about the multiple linear regression. So for the multiple linear regression, this is actually the strength of the relationship that we have talked about last time. So this is sourced in the study of Evans in 1995, straightforward statistics for behavioral sciences. Well, we can also use these metrics, no, for the range of correlation values. For example, if we have our Pearson R value of 0.8 to 1, that is a very strong positive, and if that's negative, then that is very strong negative relationship. For zero point 0.6 to 0.79, that's strong positive. For zero point 0.4 to 4.59, that's moderate positive. And then again, if that's negative, then you just change the word negative here. And if we have the very weak positive of zero point 0.0 to 0.19, and so meaning to say that that has a very weak value already. So multiple linear regression is also known simply as multiple regression. So it's a statistical technique that uses several explanatory variables to predict the outcome of a response variable. So this is an extension of a linear regression that we have talked about last time that uses just one explanatory variable. We can know, or we can use multiple linear regression to know how strong the relationship is between the two or more independent variables and one dependent variables. For example, you have the amount of rainfall, the temperature, and amount of fertilizer affects the growth, or sorry, the crop growth, no? And we would want to know the value of the dependent variable at a certain value of the independent variables. So we want to know the expected yield of crop at a certain levels of rainfall, temperature, and fertilizer addition. So first, we would want to know if there is a relationship between the rainfall, the temperature, and the fertilizer to the crop growth or the growth of the plant or the crops. So if there is no relationship between these variables to the crop growth, then of course we cannot, we neglect that variable. So how would we know that? If that has a very weak positive or very weak negative relationship? We omit that variable to our dependent variable, which affects the crop growth. For example, we found a very weak relationship between the crop growth and the independent variable um, temperature. So meaning to say, hindi naman walang relationship talaga yung temperature sa crop growth. So we remove temperature, of course, to our final model, no? So the formula and calculation of a multiple linear regression here are as follows. So remember in our linear regression, we only have y equals mx plus b. But here, we have several variables. Since these are independent variables, so we have to put here. And the epsilon here is the model's error, or also known the residuals. So here, again, is the dependent variable. So the continuous variable that we want to predict, like the amount of, for example, the amount of crop growth of the independent variables, rainfall, if so pag-quantify ng rainfall, for example, the strength siguro, no? Unsa ba? Temperature, how much temperature is it today that affected the crop growth, and etc. Explanatory variables are the x sub. Y-intercept is this one, the constant term. Okay. The b sub p are the slope coefficients. So we will have an example. So we are studying in engineering how various components and conditions of concrete mix influence its compressive strength. The independent variables are the quantities of cement aggregate used, the water to cement ratio, and the age of the concrete. The dependent variable is the compressive strength of the concrete measured in megapascals. So the goal is to use multiple linear regression analysis to determine the relative influence of each component of the strength of the concrete and to predict the strength based on these factors. This analysis is crucial for designing concrete mixes that meet specific strength requirements for different construction projects. So we have here independent variables such as the cement. We also have the fine aggregate, the coarse aggregate, the water to cement ratio, and age. So we would want to know if there is a relationship first between this and the compressive strength of the concrete. So we have our data here. Share. So the data is this one. This is actually, again, assimilated data. So noon, our previous sample was only linear regression. So meaning to say there's only one variable that affects the other variable. So independent to dependent. But here, of course, there are several factors that affect a dependent variable, right? So we want to know if these variables here, or we want to predict, or we want to know if these variables here has a relationship to the compressive strength. And afterwards, if there is a relationship between this and that, then we can already predict the compressive strength of a certain value. So what do we mean by that? So we will we are going to export. Okay, export. Sorry. Open computer. Saan siya nakasave? Yan. So ayan siya, no? And then we just go to regression and then correlation. So age in days should be continuous or a scale as well. Hindi naman siya ordinal, no? So everything is a scale, sample number, hindi siya kasali sa analysis. So we have the variable cement, the fine aggregates, the coarse aggregates. Pero ang sabi ko before, the dependent variable should come first, no? And then susunod na yung iba. Okay? So, yan. Let us compare now. Cement and compressive strength, check. Meron silang relationship, right? Because of 0.675 Pearson R value, and there's a significant difference between them. So 0.675, and that falls under strong positive relationship. Fine aggregate naman and the cement, tingnan natin siya, fine aggregate and the compressive strength. Okay? So, tingnan natin ito, class, yung independent variables to the dependent variable na compressive strength. Fine aggregate and the compressive strength, that's very strong a strong negative relationship. Coarse aggregate, remove because there is a very weak negative relationship to the compressive strength. Water to cement ratio, there is a strong negative relationship. And age, there is a strong positive relationship. So, kani siya, except sa coarse aggregate, has a relationship to the compressive strength. But, there is a term that we call multicollinearity. What do we mean by that? So, multicollinearity happens if both independent variables Pearson R value are 0.7. So kung titingnan po natin yung fine aggregate at saka yung cement, 0.988. So ito siya at saka ito, class, can be removed. Pwede natin siya i-remove kasi they are multicollinear. Ano bang ibig sabihin nun? So we can just choose among one of these variables. Kasi parang the same lang sila ng parang yung dating is they almost have the same effect to the dependent variable. So, you can just choose one, di ba? So, kung ako ang papipiliin, I will choose kung cement, ilan ba yung cement? Cement, kaysa sa fine aggregate. And then, coarse aggregate, wala siya, no? Kasi nga, hindi siya, si water to cement and cement, same lang din, di ba? So, pwede din natin i-remove actually si water to cement as well because it's multicollinear to fine aggregate. And fine aggregate and cement is also multicollinear. Si H naman at saka si fine aggregate, wala. Hindi siya multicollinear because of the value of 0.107 as well as negative 97. So we can actually remove itong tatlo because again, multicollinear siya with cement, si fine aggregate, tsaka si water to cement. Si coarse aggregate naman, there's a very weak negative relationship between them. I hope you understand that, no? So if you have any questions, you message me afterwards. Now, we have already uh, the relationship. So now let's build a model using linear regression. So the dependent variable here is the comparative strength. And since we have to omit fine aggregate, coarse aggregate, and water to cement, because again, multicollinear siya. Ito, si fine aggregate kay cement, si fine aggregate kay water to cement, and si water to cement kay cement. So, yung final model natin sa covariates, ilagay natin si cement at saka si H. Is again, coarse aggregate does not have a relationship. So we only have dalawang independent variables left that affects our model. So, titingnan natin siya class, the R squared is 90.8. It's very high, di ba? Kung ilagay natin to siya mga multicollinear values, magiging redundant yung model, guys. Di ba? So, since again, ito multicollinear, coarse aggregate is not or does not have a relationship with the compressive strength, fine aggregate is multicollinear to cement, then we can remove them. And then we can have our final value or final model as y equals, where is that? So, tingnan natin sa unstandardized 3.045 plus 0.068. For example, let's name that sub 1, yung cement, no? Ang sub 1. Then 0.501 x sub 2 plus yung epsilon. Paano ba yung epsilon? Epsilon. Or pwede nang wag lagyan ng epsilon. Kasi nga may residuals or yung error left which is about 10% or 9.2% na kailangan pa nating hanapin that affects the compressive strength. So, x1 where x1 is the cement and h is the x2. Ayan siya. So, for example, our cement value is around 285. And then, ang H natin is 12.5. So, if we use our calculators, anyway, that's 0.068 times 285 to 9 plus, so 19.38 siya. 0.501 times, yung H is 12.5, 6.2625. I-add natin lahat. Plus 19.38 plus 3. So therefore, our compressive strength value is 28.69 and MPa. So this is 90% accurate, 90.8% accurate. That if our if our X1 cement has a value of 285 kilograms per cubic meter, and that is 12.5 days old, then we have a compressive strength of 28.69 MPa. So please do the lab exercise for you to practice as well. I hope this is clear. And again, if you have any questions, I would be glad to answer that. Thank you so much for listening.